Hello and welcome to my channel. In this video, I will be explaining about resistance welding. So what is resistance welding? So resistance welding is a plastic welding or pressure welding where we use the resistance of electricity and by the help of pressure we join similar metals or very thin plates or similar materials of wires. This is resistance welding. So we are using the resistance of electricity, that is the ampere of the electricity, current of the electricity, not the voltage. So resistance welding is a plastic welding process in which heat is generated by the electrical resistance of the material to the flow of electric current through it while pressure is applied to form the joint. So here we are using electric current, and by the using of the electric current, heat is generated between the two metals. The heat is generated due to the resistance of the electricity, and when we are passing electric current through the materials which will be joined, and we also apply pressure. That's why it is called pressure welding or plastic welding. So we are melting the metal to the plastic state. That's why it is also called plastic welding. So we are using electric current or using pressure, and we are forming the welding joint. Here we no need of filler metal, flux or any kind of shielding gas. This is resistance welding. So what are the main components of resistance welding? So in this figure we can see the setup of resistance welding. So to weld in resistance welding or to join two kind of materials, we need a resistance welding machine. So this is the front portion of resistance welding machine. So this one and this one is the parent metal which will be welded in a particular area. So this is tongue and this is also tongue, and this is electrode and this is also electrode. So electrode is used here, it is non-consumable. It is used to pass the electricity and to apply pressure both on the parent metals. So here we need power supply. The power supply will be very low in voltage, usually 4 to 12 volt, and the very high range of current near about 1000 ampere to 1 lakh ampere depending on the process or depending on the metals we are welding. So next is electrode. So it is made of mainly copper. It is made of copper or copper alloy. Why it is used copper or copper alloy? Because the copper is superconductive of electricity. So here we are using electricity to create resistance here. So we need superconductive of materials to flow the electricity. So here we are using copper, the superconductive of electricity. And also the copper electrodes apply pressure both on the parent metals. Next, the workpieces. Usually it is of thin sheet or wires of similar materials. So here in resistance welding we need to weld the similar metals. We can't weld the dissimilar metals. Next, the controller. The controls the duration of current flow and pressure application. It is mainly the experience of the previous one's welding. So it is set like a duration. That duration controls the flow of the current, and pressure is applied manually here. So here we can see that this is power supply. This is AC power supply, not DC power supply. It is AC power supply. Here we need a welding machine, that is resistance welding machine, and the machine will convert the AC power supply to voltage between 4 to 12 volts and the ampere between 1000 to 1 lakh ampere. So the power supply is connected directly to the electrodes, and we place the materials which will be joined together, similar materials, between the electrodes and provide support to them, and we apply pressure. Here the one electrode is fixed, can't move up and down, and another electrode is movable. It can move up and down. It is fixed. It cannot move up and down, but it can move up and down. So when we need to increase the gap between these two electrodes, we move the upper electrode to upwards and place the parent metals, and after placing we apply pressure on the upper electrode to apply pressure on the workpiece, and after the application of pressure we give supply, AC power supply to the electrodes, and after a short duration the contact area fuses and mixes with each other, and after solidification we release the pressure and we get the welding joint. Here we can see that this is very small portion that is getting weld. The red portion is getting weld. So in this figure we can see the raw portion of the resistance welding. So this is electrode and this is also electrode. We apply pressure by the electrodes on the parent metals. This is one parent metal and this is another parent metal. This is one, this is two parent metals. And when we are applying pressure, we power on the AC power supply, and after a few time we disconnect the AC power supply, but the pressure remains constant. After a few time, when this portion getting solidified, we release the pressure and get the weldment or welding joint. So why this is happens? So this is happens because of the electricity. So here the current is flowing through the electrodes and through the transformer. So this is the complete circuit. So when the electricity is coming through this portion, the density of the electricity or the ampere is much more between these areas. Between these areas the ampere is very high. So by the ampere, the portion, this portion getting high resistance, and because of the high resistance heat is generated, and by the heat the metal where we apply more pressure, the metal fuses and mixes together, and after when the AC power supply is disconnected and pressure is constant, then the portion is solidifies, and after the solidification we release the pressure and we take out these workpieces and get a welding joint or weldment. So here the workpieces are clamped between the two electrodes. Pressure is applied through the electrodes. A high electric current is passed for a short time. Heat is generated at the interface due to resistance. The metal softens or melts locally. Pressure is maintained while the current stops, allowing the weld to solidify and form a nugget or joint. So this is the working process. So there are few types of resistance welding. The main three types of the resistance welding are spot welding, seam welding and projection welding. So in the next videos I will discuss about these three methods. But resistance welding not only of these types, also there are so many types, but main types of only these three. So what are the advantages of resistance welding? So it has high production rate, that is process is very fast, no filler metal, no flux or no shielding gas required. So we no need to clean the welding joint after the welding. Clean and strong weld, it is clean and strong welds provides easily automated it can be easily automated by the robotic welding and suitable for sheet metal and mass production, though it has some limitations or disadvantages. high initial equipment cost. So initial cost of the equipment are very high, limited to thin sheets or small cross sections, requires high current supply, joint strength may vary with surface condition, also not suitable for non-conductive materials. So if we want to join the non-conductive materials, it is impossible. What are the applications of resistance welding? So in automobile, body manufacturing, sheet metal assembles, aircraft and shipbuilding, wire and chain making, fuel tanks, radiators and drums, and electrical components. So these are the applications of resistance welding. So in this video, I have discussed about resistance welding. Hope this video was useful for you. Thank you for watching this video. For more updates, subscribe this channel and hit the bell icon.